Okay, I asked you to at least try this one all by yourself. And I want to just point a few things out on my graph. I have a vertex at -3, -1. It is a minimum because my positive parabola is smiling. I have roots of -4 and -2, and they're each one away from the line of symmetry. My y-intercept was 8, so I moved up to 8. I noticed that that is 1, 2, 3 units to the right of my line of symmetry. So if I go back to the line of symmetry and move 1, 2, 3 units to the left, I was able to add another ordered pair, -6, 8, and that makes that beautiful parabola. Now, if you did not do the second one, I said you could or you didn't have to. The reason I kind of said not to is I realized our vertex did not really fit on the graph. So take a moment, pause this video if you did not do this one by yourself without staring at the video. See if you can get the same answers as I did. I included my y-intercept. Take a moment, pause the video if you didn't do this one, and try, and we can compare answers. So go ahead, pause that video. Thank you for pausing the video. I appreciate you giving it a whirl. Hopefully yours looks very similar, if not identical to mine. Next, we're going to try one. It kind of looks different, but we're going to approach it exactly the same. This one is just a binomial. We could add +0, so we have an A, a B, and a C. But we'll start the same. We have a line of symmetry. X equals the opposite of B. Ooh, divided by 2A. This time A is 2. So we have -8 divided by 4 to get -2. So my line of symmetry is at where x equals -2. So draw that in. X equals -2. Now we go to the vertex and ask yourself, will we have a min or a max? How do we know? This is positive, meaning we're smiling, so we're going to have a min. I will put -2 in for x. Be very careful when you're squaring with negative numbers. So order of operations, -2 squared is 4. 4 times 2 is 8. That would be -16, so I end at -8. My vertex is -2, -8. It is a minimum. I get the -2 from the line of symmetry. So 1, 2, 3, 4, 5, 6, 7, 8. Right there. -2, -8 is my vertex. It is a minimum. Now we will move on to our roots, known as the x-intercepts, the zeros. Oh, this is just a binomial. So I'm going to look for the greatest common factor, which is 2x. If I distribute backwards, I would need x to get back to 2x squared plus 4. All right, we'll just set each term equal to 0. One of my roots is right here at the origin, where x equals 0. Then I will set x plus 4 equal to 0 and x equals -4, which makes sense because this is 2 to the right, 2 to the left, x equals -4. And doing the best I can, I have my parabola. Ooh, remember we used to call this one prime in Unit 9. I wonder what this prime parabola is going to look like on the graph. Well, we're not going to change our process. We're going to start with the line of symmetry, x equals O. There's no b, so I have 0 divided by 2 times 1. That is 0. So right here on the y-axis, that is my line of symmetry. All right, that's unique, but not a big deal. Now we're going to find our vertex. We know it's going to be a minimum because A is positive. I will use my LOS of 0, so 0 squared plus 3 equals 3. So my vertex is 0, 3. It is a minimum. I got the 0 from the line of symmetry, so 1, 2, 3. Okay. It's hard writing on these graphs. Make sure you guys can read that. But now we talked about that. We cannot factor that. So to find our roots, the x-intercepts, the 0, remember we used to call that thing prime, but we can't do that anymore. No, we can still graph it. There is a graph that exists for this. So we have to make our little t-chart. Yuck. Kind of, not my favorite thing to do. One thing I know, this is the vertex. This is the middle of the parabola. So I'm going to put the ordered pair 0, 3 right in the center. That's my vertex. That's the middle, the center of the parabola. Okay? The 3 is our line of symmetry. That's the folding point. So I will go -1, -2, and then I'll just go 1, 2 in that direction, add a few points so I can get a beautiful picture. I will substitute -2 into the equation, solve for y, so that would be 4 plus 3 is 7. I will then put -1 into the equation. 1, that's a 4. We have that done already, so now I'm going to put +1 into the equation. So 1 squared plus 3. Oh, that's 4. Put 2 in for x, y equals 2 squared plus 3. Oh, that is 7. Notice even on our table, around the center of the parabola, our numbers are mirroring. Well, perfect. That will make graphing it okay. So I'm going to graph the ordered pair -2, -7. So 1, 2, 1, 2, 3, 4, 5, 6, 7. Then I'm going to do -1, 4. Now I have to do +1. Oh, that kind of makes sense. Notice the mirror. It's 1 to the right, 1 to the left. So now we move 2, 7. 1, 2, 3, 4, 5, 6, 7. Again, I could have predicted that. 2 to the left, 2 to the right. Now, in our old unit, we would call that prime because we couldn't solve. Notice that our parabola does not touch the x-axis. When it does not cross the x-axis, it has no real roots. Because remember, roots stand for the x-intercepts or the zeros. We can't set it equal to 0. Mathematically, it's prime. So no real roots means no x-intercepts. That will become more prevalent later. All right, I would like you to do the same thing to the math problem below. If you want to, why don't you go ahead and pause the video. We're going to kind of give it a whirl. At least find the line of symmetry and the vertex before you hit play on the video. Find the line of symmetry and the vertex for me before you hit play on the video.